Hello everyone, this is Anil. In this video, we'll talk about Nvidia Metropolis NIM workflows. These workflows are video language models which will help us chat with a photo and a video. So let's get started. So for the purpose of this session, I have taken this photo. This is a photo of a guitar which is leaning on a bag, and it's a yellow color guitar. And then the video is a video recording from a mall where there's a dinosaur park, and then there are people in the mall, and so on. Now let's see how the model can explain the photo and video. The code is available on Git repo, where this is from again NVIDIA. So Metropolis NIM workflows. I'll post the link to this. Now here they talk about how to clone, which report to clone, and then what is the API key that we have to use to interact with this language model. I have cloned this on my Jupyter Notebook, this workspace here. And if you see the folder structure, it has workflows and it has README assets and all of the other stuff. So within workflows, we have VLM alerts. That is where I'm interested in. So here I have uploaded an image called Anil test image, which is the same guitar image that we have seen. And also have uploaded a test video, which is the dinosaur park video we have seen. Now, NVIDIA has supplied this workshop Jupyter Notebook, which we'll be executing. So as you can see here, this is the notebook. And again, it has different parts. The first part is setting up the environment. The second part is text chat, image chat, and video understanding. As part of the session, we will do the setup environment, we'll do the image chat and video understanding, these three pieces. So in order to set up the environment, there is a requirements folder, which is requirements file, which has the different installations to be done as part of the pip. So there's notebook, there's OpenCV, Python, and so on. So I have run this already, the setting up part. And now wherever we have to update specific information for our use case, like the video name, the file name, or the API key from NVIDIA. So those are mentioned in this notebook with a keyword called fix me. So that way you know that you have to go and update that section or that variable, right? So that I have done already, and then I have run this requirements text, and there are no errors. It successfully installed all the required packages. And if I keep going, I have executed the required NIM URLs as well. So as part of this video, we'll also see, or as part of this notebook, NVIDIA also has given us how to compare different language models and how they respond to the same image. So we'll see that as well. Now, the first one is just talks about understanding simple prompt where we are saying, can you tell me what you're capable of? And then it tells you that it is a assistant, and then it is capable of all these things, right? Let's keep going. And then we'll start with the image chart. So here they have given an image, which is a test image for us to understand how to use this. So we'll start by executing that. So it will process the image, and then it will run a test prompt against that. So where it is trying to describe the image. And next is the place where we try our own image. So when you run the prompt on the test image they have given, which is this one here, it tells us that this image has a highway, and then there are some vehicles and so on, which is what you're seeing on the image, and there's some traffic and so on. Next, in our image, we have a guitar. So let's see what it responds to that. So if you can see here, it's saying that the image shows a guitar leaning against a bag, and then the guitar is yellow, it has a sticker on it and so on, which is this one here, right? Which is fairly accurate. Now let's continue this, and then we will see how the video, how it responds to a video. Now, as I mentioned, there is a section where it also compares different VLMs. So this we can see here. Now this is against the test image they have given, the highway image, where you can see that each model responds to the image differently. So Neva responds saying that image shows a highway during golden hour and all of that. And then Fuyu responds saying that image depicts a busy highway filled with numerous cars. And then 5.3 responds saying image captures a serene scene of highway during what appears to be either sunrise or sunset. So each model again has a different response, but they explain the image fairly accurately, but with a different construct or understanding of it. Right now, let's keep going. So we'll look at the video response. So let's go to that section, just section 3, video understanding. So we'll run this part here. So as you can see here, my video has a dinosaur park inside a mall, and then the park is decorated with plants and dinosaur statues, all of that. And there are people visiting the park. So it is able to explain all that. So as you can see here, this video has a dinosaur park and then the people and the plants and everything, right? That's what it has done. It has explained all of that here. So now, if you look at this piece of code, it is helping us run a loop and then continuously ask a prompt. So the idea behind this is if there is a large video clip and then in that video, if you want to ask a specific prompt that, let's say, is there a dinosaur in the video, in the image, right? Let's try this and see what happens. And then it is able to understand that there is a dinosaur statue in the image. So that is the main idea of this, this use case, right? So it is able to look at the whole video and then explain and answer a specific prompt based on the content. So again, there are numerous use cases to it. There is a Nvidia webinar and so on. But again, what I want to demonstrate is that this is the VLM that is available, or these are a set of VLMs that are available from Nvidia, which will help us interact with image and the video. So thanks for watching. This is Anil.